Hello everyone, this is Sir Don and we are now going to divide rational algebraic expressions. In this video in dividing rational algebraic expressions, students are able to divide rational algebraic expressions. So the process here is almost similar with multiplying rational algebraic expression, but the only difference is that first thing, you're going to get the reciprocal of the divisor and change the operation to multiplication and then perform the operation. Then, you have to express the numerators and denominators into prime factor if possible. As you can see, this is the first step in multiplying rational algebraic expressions. So I will be writing here also the processes in multiplying rational algebraic expressions for you to master the skills in multiplying rational algebraic expressions. So next is that you have to multiply the numerator by the numerator and denominator by the other denominator. Then you have to divide out the common factors in the numerator and denominator. And you have to simplify the remaining numbers in the numerator and denominator. As what I have said, there is only one step which is added in this process, and that is finding the reciprocal of the divisor. For you to understand that process, let's have this illustrative example number 1. The problem is that we are going to find the quotient of 2xy over 40 divided by 10x squared over 8. So when we say quotient, that is the answer in dividing two numbers. Okay, so we have now the solution. We have 2xy over 40 divided by 10x squared over 8. So the first thing that we are going to do is you are going to get the reciprocal of the divisor. So this one is the dividend and the other one is the divisor. So to get the reciprocal of the divisor, we're just going to interchange the position of the numerator and then the denominator. So this 10x squared here as the numerator will become the denominator. Then 8 here will become the numerator. So when we say reciprocal again, we are just going to interchange the position of the numerator and denominator and proceed to multiplication. From division, we proceed to multiplication. Then, we are going to perform the operation. This time, we are going to multiply. Express the numerators and denominators into prime factor if possible. So 2xy, the prime factors, 2xy, 40. Prime factors are 2 times 2 times 2 times 5. 8, that is 2 times 2 times 2. Then 10x squared, that is 2 times 5 times x times x. Again, make sure that all numbers here or all values are all prime numbers. Then multiply the numerator by the numerator and denominator by the other denominator. So we have here 2xy, 2 times 2 times 2. 2 times 2 times 2 times 5 times 2 times 5 times x. Then divide out the common factors in the numerator and denominator. What we're doing here is that we actually divide. But since dividing a number by itself will result to 1, so we're just going to cancel the two terms, the two values. And that leads to cancellation. So we have here 2 and 2. 2 and x and 2, x, these are terms that have, or these are values that have or are the same with the denominators. Okay, so as you can see, we have here 2 divided by 2 will result to 1, x divided by x will result to 1, 2 divided by 2 will result to 1, and 2 divided by 2 will result to 1. So the numbers that are not cancelled, we also have 2 and then 2. So the numbers that are not cancelled are y, because there is no y in the denominator, 5, there is no 5 in the numerator, and then x, there is no x in the numerator. So that is why the remaining values are y all over 25x. 25x comes from 5 times 5 times x. So y is just copied since all values here are 1. So 1 times 1 times y times 1 times 1 times 1 is equal to y. And 1 times 1 times 1 times 5 times 1 times 5 times 1 times x is 25x. Okay. Our second example is we are going to divide x squared minus 1 over y squared minus 2y plus 4 by 3x plus 3 all over 15x. So again, you have to go back with the factoring technique so that you can easily factor out these polynomials. Okay, so let's have the solution. So the given is x squared minus 1 all over y squared minus 2y plus 4 divided by 3x plus 3 over 15x. So we have here get the reciprocal of the divisor and change the operation to multiplication and perform the operation. So get the reciprocal of the divisor. This one is our divisor. To get the reciprocal, interchange the numerator and then the denominator. So we have here 15x over 3x plus 3. Express the numerators and denominators into prime factor if possible. So the factored form of this difference of two squares is the sum and difference of a binomial. That is the quantity of x plus 1 times the quantity of x minus 1. So y squared minus 2y plus 4, so this one is not factorable, so we're just going to retain it, times 3 times 5, these are prime numbers, times x, then we have here 3x plus 3, this can be factored out using greatest common monomial factor. Then multiply the numerator by the numerator and denominator by the other denominator. We are just going to compress. Then after this, we're going to look for values which are similar in the numerator and denominator so that we can cancel those values because dividing by itself will result to 1. So we have here x plus 1 in the denominator. We also have here 3 and 3 in the denominator. So as you can see, there is no other values which are the same or present in the numerator and denominator. So we can proceed to the next one, which is simplifying the remaining numbers in the numerator and denominator. So we have here, the remaining values are 5x and the quantity of x minus 1 here, and y squared minus 2y plus 4 here. So the answer is 5x times the quantity of x minus 1 all over y squared minus 2y plus 4. Or you can distribute this one. This will become 5x squared minus 5. If this one is factored form, that is also correct. Okay, our third example, we are just going to find the quotient of 2x squared plus x minus 6 all over 2x squared plus 7x plus 5 and x squared minus 2x minus 8 all over 2x squared minus 8 minus 20. Okay, so let's proceed with this solution. So we have here the given that is 2x squared plus x minus 6 all over 2x squared plus 7x plus 7 divided by x squared minus 2x minus 8 all over 2x squared minus 8 minus 20. Again, the first step, we're just going to get the reciprocal of the divisor. So this one is the divisor. The reciprocal of that is 2x squared minus x minus 20 all over x squared minus 2x minus 8. Then proceed to multiplication. Express the numerator and denominators into prime factor if possible. So this one, you're going to factor out the numerators and denominators. You have to go back with the factoring techniques again. So the factored form of this is 2x minus 3 times the quantity of x plus 2. The factored form of this one is 2x plus 5 times the quantity of x plus 2. Here, the factored form is x minus 4, quantity of x minus 4 times the quantity of 2x plus 5. Here, the factored form of this one is x plus 2 times the quantity of x minus 4. Then multiply the numerators by the numerator and denominator by the other denominator. So in multiplying, you're just going to compress this so that you can see which values can be cancelled or which can be divided. Then divide out the common factors in the numerator and denominator. In dividing again, you can cancel if these values are the same. So x plus 2, that is x plus 2. We have x minus 4, then we have x minus 4, then 2x plus 5, and 2x plus 5. So x plus 2 here can also be divided by here. So this is just the same. So the remaining values are, which are retained, we have 2x minus 3 here, the numerator, and then the denominator is x plus 1. So therefore, the answer is 2x minus 3 all over x plus 1. Okay, so that's it. In dividing a rational algebraic expressions, you have to be reminded of this one. So the quotient of two rational expressions is actually their cross products in symbols, that is a over b divided by c over d. The quotient of that is their cross products, which is ad over bc, wherein bc should not be equal to 0. But since we can cancel terms here, so this value or this concept can be, or the values here is lesser compared to the expected one. So thank you very much for listening. Hope that you learned something for today.